This is the story of how a single label, 3 letters long, scribbled on a presentation slide in September 2019, led to the discovery of an entirely new class of cosmic object that nobody predicted and nobody can fully explain. Odd radio circles, or ORCs, rank among the largest and strangest structures ever found in the universe. Ghostly rings of radio emission stretching up to 1 million light-years across, surrounding distant galaxies, visible only to radio telescopes. And if you've heard them connected to something called Pluribus, we need to clear that confusion up right now, because the answer matters. A massive radio survey called EMU, short for Evolutionary Map of the Universe, had just started collecting its first data in 2019 using ASKAP, a powerful array of 36 radio dishes in Western Australia. Over 400 astronomers across 21 countries contributed to this survey, and the ambition behind it was staggering: to catalog approximately 70 million radio sources with about 40 times more sensitivity than any previous sky survey. Dr. Anna Kapinska was browsing through that brand new data when she spotted something that matched no known class of astronomical object, a faint ghostly circle of radio emission. She labeled it, and this is the exact word she used: WTF? Now here's the beautiful part of that story. EMU actually had a formal component called the WTF project, built specifically to mine the data for unexpected discoveries. Kapinska was both genuinely bewildered and accidentally invoking official survey protocol at the same time. Ray Norris, the astrophysicist leading the EMU project, later described what they found as a ghostly circle of radio emission, hanging out in space like a cosmic smoke ring. His own reaction captured the mood perfectly. "None of us had ever seen anything like it before," he admitted, "and we had no idea what it was," confirming a new class of object. Over the following months, Norris's team identified 3 of these circles in the ASKAP data, labeled ORCs 1, 2, and 3. A 4th one turned up hiding in archival data from India's GMRT telescope, and that data had been captured all the way back in 2013. ORCs 4 had been sitting there for years, imaged but unrecognized. What followed was months of systematic elimination, ruling out equipment error, software artifacts, and every known class of radio object, one by one. These circles were far too large to be supernova remnants. They weren't planetary nebulae, weren't gravitational lensing artifacts, and weren't imaging glitches, because multiple telescopes confirmed them independently. On June 26, 2020, the team posted their discovery paper to ArXiv under the title "Unexpected Circular Radio Objects at High Galactic Latitude," and it eventually landed in the publications of the Astronomical Society of Australia in 2021. Norris reflected on the moment with real emotion. "I've waited my whole life to find something like this," he told interviewers. "I wish I was like 20 or something and had the rest of my life to study them," and that's when he made an admission that surprised people. "I thought we would need artificial intelligence techniques to find them," he explained. "But in the end, the good old human eyeball turned out to be the best way." What are ORCs exactly? Picture a faint, edge-brightened ring of radio emission surrounding a distant galaxy, completely invisible in optical and infrared light, visible only to radio telescopes. That glow comes from synchrotron radiation, produced by relativistic electrons spiraling around magnetic field lines. Most confirmed ORCs have a massive elliptical galaxy sitting dead center, with stellar masses around 100 billion solar masses. On the sky, a typical ORC spans about 1 arc minute, which is roughly 3% of the Moon's apparent diameter. That sounds tiny, but at their actual distances, that angular size translates to physical diameters of 300 to 500 kiloparsecs, or roughly 1 to 1.6 million light-years across. Our Milky Way stretches about 100,000 light-years in diameter, which means ORCs dwarf it by a factor of 10 to 16. Norris pointed out a detail that puts the discovery in context. Just a few years earlier, no radio telescope on Earth could have found them. ASKAP's wide field of view, covering 30 square degrees or the equivalent of roughly 150 full moons, was the technology that made the detection possible. The race to explain them. Once ORCs were confirmed as real, the obvious question became, what creates a million light-year radio ring around a galaxy? 4 serious theories emerged, and each one carries real observational and simulation support. Starburst-driven galactic winds came first. Galaxy mergers trigger intense star formation. Massive stars detonate as supernovae, and those explosions drive galactic winds at roughly 2,000 kilometers per second for about 200 million years. That expanding spherical shockwave pushes into low-density intergalactic gas and produces synchrotron emission at the shock front. In January 2024, astronomer Allison Coyle at UC San Diego published a paper in Nature based on Keck observatory observations, and what her team found in ORC-4's host galaxy stopped them cold. Her words were, "There was this absurd amount of oxygen 2000 shocked ionized gas extending 40 kiloparsecs." A December 2025 follow-up confirmed shock velocities of 200 to 300 kilometers per second, which ruled out alternative explanations for that particular ORC. Galaxy group mergers offered the second explanation. In April 2024, Ezra Bulbul's team at the Max Planck Institute pulled off the first X-ray detection of an ORC, the Cloverleaf, using the XMM Newton satellite. They found it embedded inside a merging galaxy group with a total mass of about 26 trillion solar masses. Bulbul put it this way: "This is the first time anyone has seen X-ray emission associated with an ORC. It was the missing key to unlock the secret of the Cloverleaf's formation." A third theory proposed that remnant radio lobes from previous AGN jet activity get compressed and re-energized when hit by external shocks. And the fourth model, originally favored by Norris himself, suggested that collisions between two supermassive black holes could produce spherical shock waves. But here's the thing: Norris acknowledged that model ran into trouble when a newly discovered ORC showed an offset between its ring center and its host galaxy. The emerging picture points toward ORCs being a mixed class, where different formation mechanisms create different ORCs. The growing catalog. Since 2020, the catalog has grown at a steady pace. By early 2026, approximately 12 to 15 ORCs meet confirmed status under peer-reviewed criteria, with 10 or more additional candidates from recent surveys. Individual ORCs have picked up memorable names along the way: Cloverleaf for its appearance, Synchrotron as a Lord of the Rings nod. November 2024 brought the smallest known ORC found in Meerkat data. ORC J2195505 measured just 114 kiloparsecs, about 372,000 light-years, and that discovery mattered because it proved a hidden population of smaller, fainter ORCs exists that earlier surveys would have missed entirely. And that's when the story took its most dramatic turn. In October 2025, citizen scientists on India's Radi@Home platform, working with LOFAR data, found the most distant and most powerful ORC ever recorded. Its redshift of roughly 0.94 means the light traveled approximately 7.5 to 8 billion years to reach us. A citizen scientist named Prasoon Machado first flagged the double ring structure. He later reflected, "Contributing to Radi@Home citizen science has been a great journey, exceeding all expectations and opening my eyes to the hidden patterns of the cosmos." By February 2026, a systematic search of LOFAR data had identified 18 ORC structures, which dramatically expanded the known population. So where does Pluribus fit? Now the question in the title: are ORCs and Pluribus the same phenomenon? No, they are not. And the reason is worth spelling out clearly for anyone making or watching space content. After searching all ORC-related scientific literature, archives of papers, and astronomical databases, the name Pluribus does not appear anywhere in radio astronomy or ORC science. Not as the name of an ORC, not as an ORC candidate, not as any related astronomical phenomenon. Pluribus is an Apple TV Plus science fiction series created by Vince Gilligan, the creator of Breaking Bad, and it premiered on November 7, 2025. Its title comes from the Latin phrase, E pluribus unum, meaning out of many, one. The pilot was filmed at the real Carl G. Jansky Very Large Array in New Mexico, and the plot centers on astronomers detecting an alien signal using radio telescopes. That's compelling fiction that borrows from real radio astronomy, and it's easy to see how someone could confuse references to the show with actual discoveries. Real named ORCs in the scientific literature include Cloverleaf, Sauron, and Physalis, but Pluribus is not among them. If you encounter Pluribus discussed alongside Space Mysteries, that's the TV show, not the science. What comes next? ORCs stand as something genuinely unusual in modern astronomy. A completely new class of object discovered by human eyes browsing data, not predicted by any existing theory, and still actively debated years later. The Square Kilometer Array telescope, currently under construction, should discover many more ORCs and could resolve the question definitively. Future X-ray missions planned for the 2030s could detect ORC X-ray counterparts in about 4 hours, compared to the 11.5 days current instruments require. The arc of this story tracks science at its most honest. It started with bewilderment, a literal WTF, scribbled on a slide. It moved through careful confirmation, competing theories, breakthrough observations, and a citizen science triumph halfway around the world. None of it is fully resolved yet, and that's exactly what makes it worth paying attention to. Alison Coyle captured the feeling best when she described seeing the Keck data for the first time. It's pretty rare these days to get new astronomy data where you think, what is that? I don't even know what I'm seeing here. That sense of encountering something genuinely unknown is why ORCs matter. Not because they connect to a television show, but because the universe still has entirely new things to show us. Conclusion: why this matters more than it seems. Odd radio circles do not promise aliens, hidden messages, or secret technologies, and yet they represent something just as rare and arguably more important. They remind us that even in the 21st century, with supercomputers, machine learning, and sky surveys mapping tens of millions of sources, the universe is still capable of surprising us in ways no model predicted. What makes ORCs extraordinary is not just their size, or their ghostly appearance, or the fact that they can stretch over 1 million light-years. It is the way they were discovered, not by theory, not by simulation, but by human curiosity, by astronomers scrolling through data and stopping long enough to say, that doesn't make sense. For decades, radio astronomy focused on points, jets, lobes, and filaments. ORCs do not fit comfortably into any of those categories. They are not explosions in the classical sense. They are not relics we expected to find. They sit at the intersection of galaxy evolution, shock physics, magnetic fields, and cosmic environments we are only beginning to understand. In a very real way, ORCs force astrophysics to confront its blind spots. They also reveal how incomplete our cosmic census still is. The fact that the smallest ORCs were invisible to earlier surveys tells us that we have been missing entire populations of large-scale structures simply because our instruments were not designed to see them. This is not a failure. It is the natural progression of science. Every new telescope does not just answer questions, it creates new ones. The comparison with Pluribus, while ultimately incorrect, is instructive. Fiction often acts as a mirror for our scientific anxieties and hopes. Stories about mysterious signals and unexplained cosmic structures resonate because they tap into a deeper truth. The universe is not obligated to align with our expectations. Real discoveries like ORCs are reminders that the unknown does not need embellishment. It already exists, quietly encoded in data, waiting to be noticed. There is also something profoundly modern about this story. ORCs are not the product of a lone genius working in isolation. They emerged from international collaboration, open data, citizen science, and instruments spread across continents. A student, a retired engineer, or a volunteer halfway across the world can now contribute to discoveries that reshape entire subfields of astronomy. That is not just progress, that is a transformation in how knowledge is made. Looking forward, the implications are enormous. The Square Kilometre Array will increase sensitivity by an order of magnitude. MERCAT, LOFAR, and future X-ray missions will add depth, context, and missing pieces. With enough data, we may finally separate ORCs into subtypes, trace their life cycles, and understand which physical processes dominate under which conditions. Or we may discover that some of them still resist classification entirely. And if that happens, that would not be a disappointment. It would be a victory. Because science advances not when everything fits neatly into our frameworks, but when reality refuses to cooperate. ORCs exist at that edge. They are not errors. They are not anomalies to be dismissed. They are signposts pointing toward physics we have not yet fully grasped. In the end, odd radio circles do not tell us that the universe is stranger than we imagine. They tell us something more humbling. The universe is stranger than we are currently equipped to explain, and that gap between observation and understanding is where discovery lives. The next time a faint ring appears in the data, unnoticed at first, remember this story. Somewhere in that glow may be another reminder that the cosmos still holds surprises, not waiting to be dramatized, but simply waiting to be seen,